Good morning and welcome everybody. My name is Karen Bloor. I'm a Professor of Health Economics and Policy at the University of York, and I'm delighted to be part of the N8 Computationally Intensive Research Network, mainly to link researchers interested in data analysis in the whole healthcare area. I have a role at the university as a research champion, which means that I work across the whole health portfolio in York. Anyway, great to be able to introduce Richard Williams this morning. Richard Williams is a senior software engineer and research fellow in the Centre for Health Informatics at the University of Manchester. He's led the development and implementation of a number of award-winning web applications for reducing patient harm. And his PhD was on applying software engineering principles to electronic health records. He leads a team of software engineers investigating tools and techniques to enable health research using healthcare data which wasn't primarily collected for research purposes. And he's particularly interested in how researchers create sets of clinical codes for interrogating electronic health records. And that is the topic of today's seminar. So welcome, Richard.
Hi, thanks for the introduction, Karen. Yeah, so as Karen says, I've spent a lot of my time working with clinical codes, and so I've been asked to do a seminar today about sort of what they are and how you choose clinical codes for use in research. Okay, so a brief overview of what we're going to cover today. So first of all, we'll go right back to basics and just talk about exactly what clinical codes are. We'll then talk about clinical code sets and in particular why we need them. We're going to talk about how we create clinical code sets, how you find them, how you reuse them. And then I've got a slide at the end, which is just full of useful links. So I'm assuming that, well, this whole thing's being recorded, but I'm happy to share my slides afterwards. So you don't need to scribble all the links down as I go through. There's a page of them at the end. Okay, so first section, what are clinical codes? So very simply, they are alphanumeric codes that represent clinical concepts. So it'll be a string of numbers or letters, and it will be used to represent anything that you might come across in a clinical practice. So the list there shows it might be diagnoses, medications, symptoms, results, procedures. But you also get codes for things like occupations or administration codes. So for instance, you'd get a code saying that a third text message reminder has been sent to someone to remind them to book their COVID vaccination. So absolutely anything you could think of in medical practice will have a code. So some examples, the code N2142 is equivalent to the concept periarthritis of the wrist. And that is if you're using the coding system called CTV3. I'll come on to different coding systems shortly. H25.1 would mean senile nuclear cataract, and that's using ICD-10. ICD-10 is a terminology usually used in secondary care, or particularly in this country anyway. 8867-4 is equivalent to the heart rate, so that would be a measurement. 119, etc., is a Snomed code, meaning a COVID-19 mRNA vaccination. And so what you can see there is that these codes obviously adapt over time, and new ones are appearing all the time. You also get quite bizarre ones. So U0326 means passenger of three-wheeled motor vehicle injured in collision with animal. I'm not sure this sort of thing happens that often, but you'd be comforted to know that there is actually a code for it. And one of my favorites, U10F2, which means fall from cliff occurrence at school. I'm willing to bet this probably has never happened. So they're clinical codes, so we know what they are now. So how do we get them? What do they look like? So typically you would have what's called a clinical code terminology or dictionary. And the reason why it's called a dictionary is because if you imagine the codes, it associates the codes with their definitions in the same way that a dictionary gives you definitions of words. Now, pretty much all terminologies, or at least all the ones in use in primary care in this country, are in a hierarchy. So here's what the hierarchy might look like. At the top, you would have a root code, which would just stand for concept. So all codes are an example of a concept. Beneath that, you might have some sort of high-level concepts like medication, diagnosis, symptom. And the way you read this hierarchy, I should say, is that as you work up it, they're what's known as is-a relationship. So you would see the word medication, you'd go up the tree to its root and you say medication is a concept. So basically medication is a thing, diagnosis is a thing, symptom is a thing. If we carry on going down this hierarchy, you can see underneath medication, one of the children of medication would be the whole category of antihypertensive drugs. Beneath that, you might have an example of an antihypertensive drug, which is a category of drugs called ACE inhibitors. And then a child of that might be an actual type of ACE inhibitor, so ramipril. So just to go back up the chain, you would say ramipril is an ACE inhibitor. An ACE inhibitor is a antihypertensive drug. An antihypertensive drug is a medication, and a medication is a concept. To give that a concrete example, there's a terminology called read code version 2, which until quite recently was, I'd say, the dominant coding system in UK primary care. It's currently been migrated. I'll talk a bit more about that later. But within that, you would have the root code, which was just 5 dots, and that basically just means this is a read code. The child of that would be B ... and that's the category of drugs called cardiovascular drugs. Beneath that, BI means ACE inhibitors, BI6 is ramipril, and BI6 capital E is an actual packet. So this is ramipril 10 milligram tablets. So this coding system is what's called a prefix hierarchy. So you can see that BI6 being ramipril is a child of BI, and that's a child of B. So if you look at the prefix of your code, you can usually tell what it is. Now, the issue with read code version 2, and one of the reasons why it's being changed, is that when it was introduced, they decided that it would be a 5-character code. So all codes are 5 characters, but that means you can at most have 5 levels of hierarchy. If you need a 6th level, you just can't have it, and you need to sort of mess around and put it in the wrong place. It also means each code has at most 1 parent. So BI can only be the child of B because that is the prefix of BI. And it is useful in some ways to be able to have more than 1 parent, but in read code you can't. Now read code itself and this sort of prefix hierarchy is very similar to another terminology called ICD, and as I mentioned before, that's what's used in secondary care in the UK. Just to give a slightly more complicated example, so this is what Snomed looks like. So as you can see, we're starting at the top with a Snomed concept, and right at the bottom we've got our ramipril 10 milligram oral tablets. You can see here that there's now far more than 5 layers of hierarchy. So before we just had medication, whereas now we've got a pharmaceutical product and a medicinal product. I'm not entirely sure what the difference is between those because I am not a clinician, but a medicinal product is a pharmaceutical product, and a pharmaceutical product is the concept. Within medicinal product, instead of before we went straight to ACE inhibitor, but now there's another category which is just products containing enzyme inhibitors, of which ACE inhibitor is just one example. ACE inhibitor goes to ramipril, that's the same as before. But you notice now there's a separation. You've got a code for a product containing ramipril. You've got a code for product containing only ramipril, and this is because you can get drugs in sort of polypills where there's more than 1 drug in a single pill, and so presumably there are other codes for product containing ramipril and something else. And then from that you then go to product containing only ramipril in oral form, and then you get down to the tablets. So again, you'd have codes saying products containing only ramipril in well, any other form you can think of. Now this is sort of, I guess, showing you single inheritance. So each thing just has 1 parent, but in fact, it is slightly more complicated than that. So for instance, there's also a concept called product containing ramipril in oral form. And so you can see that a product containing ramipril in oral form is a product containing ramipril, but in the same way that a product containing only ramipril is also a product containing ramipril. And this code down here has 2 parents, because a product containing only ramipril in oral form is a product that only contains ramipril, and it also is a product in oral form. There's then another code, product in oral form, and so there's actually another way you can sort of navigate this tree and get back to the root, because you can say that a product containing ramipril in oral form is also a product in oral form. It's also a medicinal product. Now, obviously, at first glance, this now seems very complicated compared to what seemed more straightforward before, but it's so much more powerful now, because if you imagine, if you wanted to do a study investigating, I don't know, I'm making this up because I'm not a clinician, but say you thought there was a link between products in oral form and some sort of disease of the throat, maybe throat cancer. Maybe if you take pills, you're more likely to get throat cancer. Previously, you would need to navigate the entire medical dictionary. By having multiple inheritance, so the ability for a code to have more than one parent, and by allowing the hierarchy to be unlimited, it becomes a much more powerful terminology. And so you, in theory, can just say, give me that code, product in oral form, and all of its children, because all of its children are by definition products in oral form. So the way this is done is that now the code hierarchy is separated from the codes. So whereas in read code, the actual hierarchy and the codes are related, because if you know what the prefix of the code is, you know where that code sits in the hierarchy. Whereas with Snomed, the hierarchy is stored separately from the codes and the definitions. And this makes it more powerful because you can have unlimited levels of hierarchy, and also every code can have more than one parent. Now, this is probably harder for a human to understand, because whereas previously I could look at a read code, and if it starts with a lowercase letter, I know that it's a medication. Whereas if it starts with an uppercase letter, it's a diagnosis. Whereas now, I mean, unless I've used the Snomed codes a lot, just by looking at the code itself, it doesn't give you any clues as to what it is. In your GP system, provided that when you're interacting with it, whereas before, if you could see the read codes, you might have a good idea of what you're doing. Whereas now, showing you the Snomed codes isn't that useful. But provided that complexity is hidden from the user, it's probably okay. One thing I should just point out is, if you're eagle-eyed, you'll have noticed that some of these codes are the same. That's just a typo. I did a copy and paste, and obviously didn't actually change some of those codes. So all these different definitions have different codes. The fact those numbers are the same is just a typo. Okay, so there are three main GP system suppliers. They're called EMIS, Vision, and TPP. And they each use what's called a different terminology. So Vision uses read code version 2. You saw an example of that. EMIS also uses read code version 2, but they also have their own proprietary codes called EMIS codes. And that allows them, if there's something they want to represent in their system that doesn't exist in the standard dictionary, they can just add their own code, which is great for them and great for users of the system, but it does make it more complicated if you're trying to use that data, because you need to map those codes to something. TPP. It's effectively an extension of read code. Now, having said all that, all practices are in the process of migrating, or have even migrated, to use Snomed, so that more complicated, more complete one I just showed you. But what this means for researchers is that we potentially need to use codes from many different terminologies, because even once this migration has happened and everyone is now recording in Snomed, if you're looking at any historical data, then that is going to contain read and CTV3 and potentially EMIS, because any historic data we use is likely to still contain these code systems that have been migrated away from. Now, as a quick diversion, just to, I guess, give you a rest after all that Snomed talk, I'm going to introduce a paper I wrote for the Christmas BMJ a couple of years ago. And in it, I was showing that read codes are so expressive that you can actually tell fairy tales with them quite comfortably. So without further ado, I present to you a fairy tale told using only read codes. So in case you're unfamiliar with read codes, I will go through and explain what they are. So first of all, female baby, black magic, Wiccan, puberty, accident caused by spinning machine, excessive sleep, contact with plant thorns and spines and sharp leaves, occurrence at other specified place, concussion with more than 24 hours loss of consciousness, manual resuscitation, return to pre-existing conscious level, married. And in case the spinning machine didn't give it away, that is, of course, Sleeping Beauty. We can do one more. Female baby. They all seem to start with a female baby. Pale colour, mother dead, father remarried, ran away, mining engineers, dwarfism, found dead, manual resuscitation, found dead, manual resuscitation, found dead, suspected food poisoning, manual resuscitation, married. And that, of course, was Snow White. So if there's time, I do have more of those, which I can do at the end.
There was an earlier question though saying, will EMIS clinical users still be able to add their own EMIS codes after the migration to Snomed?
So that's a good question. So just to be clear, it's not the users of the system who add it. It is the EMIS as a company who add them. So for example, when COVID first, so some systems, so Vision just reused a code which hadn't really been used before for COVID, whereas EMIS just created a code and then that was used in the system. So EMIS as a company, I suspect, may still be able to create these EMIS codes and may still want to. Potentially, if Snomed is more complete, there'll be less need to, but I guess the short answer is I don't know, but I suspect they might still do it. So I'm now going to just go through some examples of primary care databases. Now, I'm aware that this is a UK Biobank seminar, so I suspect most people here are probably coming to it from that angle, but I thought I'd go through the other primary care database in case that was useful. The three main suppliers got that data via written consent from patients who signed up to the UK Biobank. There's then also CPRD. Now, CPRD, I guess, is probably one of the biggest databases of primary care. So they get data from Vision and EMIS practices, and I think soon TPP as well. The way it works, individual practices sign up to contribute their data, and it's nationally representative, so they've got practices all over the country. You pay a fee for access, you go through an approval process, and they give you a data dump, and you do the analysis on your own machine. There's then the Health Improvement Network, which is thin, similar to CPRD, but it's just Vision practices, and again, you get a data dump on your machine. They've got a bit of linkage there to some secondary data stuff, some cancer stuff, and again, they provide extracts to researchers. SAIL is an interesting one, so they provide data from the whole of Wales. So I'm pretty sure the whole of Wales uses Vision, and so they've got all the primary care data. But they also have linkage to loads of other health data sets, so it's quite a complete data set for the population of Wales. And different to the others, you don't get an extract of data, you get access by connecting to a secure virtual desktop environment, and you do your research on those environments. And finally, Open Safely. You might have heard about this one recently. It's come in the news a few times. So they started by just using TPP practices, though I think now they may also have EMIS. And the idea behind this is you never see the patient data at all. So as a SAIL, you still see the patient data, but only on your secure environment. Whereas the Open Safely, you never see the patient data. You basically sort of create code, which you then pass over to the TPP data center. It runs locally on the patient data, and you get the results back. So that's quite an interesting model. And I'd probably be a bit remiss if I didn't mention the Greater Manchester Care Record, which is what I'm working on at the moment. So this is for the whole population of GM. We have EMIS, Vision, and TP practices. Though currently, because of restrictions, we're only allowed to use it for COVID research and only University of Manchester researchers. But in the future, hopefully, both of those will be relaxed and we'll be able to open it up to anyone and for any topic. We also have the potential to link to mental health data and social care data. So a clinical code set is a collection of clinical codes with a common purpose. Now, there's other names for it. I call them code sets, but you'll also find code lists, clinical code lists. And in the US, they call them value sets and informally even groupers. Now, these code sets are an essential starting point for all interaction with coded electronic health records. So not even just research. If you're, for example, a GP who needs to find all the patients in their practice who should be shielding, and there's a very complicated list of instructions, you need to be able to use code sets. But for research in particular, it's very important that when you're making your code sets, that you're very careful in how you do it. There have even been studies that have shown that when two teams have taken the same question, same research question, they've used the same data set, but they came to different conclusions, and that was down to the code sets that they chose. So a while ago, I did a paper where I reviewed what I called code set engineering. So I looked at how people created code sets, how they shared them, how they reused them. And there was a series of recurring themes which we pulled out. So the first thing is that people will often reuse or extend an existing code set. It makes sense. If someone has already done that work, there's no reason for you to repeat that. Though I'll come on to later that you need to take a lot of caution when you reuse or extend someone else's code set. People consider whether the code set needs to be sensitive or specific. And by that, I mean, if you want to identify a cohort of diabetic patients to see how a certain drug affects them, then you might want to ensure that everyone you get definitely has diabetes. So you want a very specific code set. You want to make sure that if you flag someone up, they definitely have it. So maybe you just include like the very clear diagnoses of diabetes. Whereas if you were, I don't know, a GP and you wanted to find people who might be at risk because it's been announced that a certain medication contraindicates with diabetic patients, you might want a more sensitive code list. People often create an initial list of synonyms. So if you're looking for type 2 diabetes, you would also look for non-insulin dependent diabetes. People take advantage of the hierarchy. As we've shown, these codes are in hierarchy. So if you found a code you like, then it's probably likely that all the children of that code are things that you're going to want to put in your code set. People do an iterative approach, and they have a review process, and they often use clinician input because researchers often perhaps don't know how these codes are used in practice, or there might be certain synonyms for those diagnoses that they don't know. And the other thing people sometimes do is they make multiple code sets and do sensitivity analyses. If you found a code and you're just not sure whether it should be in or out of your code set, what people do is they create a conservative code set, which has things in that they're sure about, and then a slightly broader code set that contains things that they think might or might not be, should be in there. They then repeat the analysis twice, and they see if there's any difference between the results. And if there isn't, then they can say, well, we weren't sure whether to put these codes in, but actually it didn't make any difference. Okay, so once we've created these code sets, now it does take quite a long time to create these. So in the interest of open science, these, I believe anyway, these should always be shared and reused. But a study in 2014 showed that actually less than 5% are. So where they found studies where people had used code sets, less than 5% of studies were actually sharing them in a meaningful way, so they could actually be reused. However, I did a paper a couple of years ago where, although it wasn't my primary objective, I was trying to find code sets, and I was looking for 20 different code sets from different authors and on different conditions. And I only need to search. I did a very similar literature search to the paper from 2014. And I only need to look at just over 40 papers to find my 20 code sets. So I'd say that wasn't the primary outcome, but it's very likely that in the past, well, since 2014, the situation is a lot better than it was. So if you're looking for a code set, then one thing to do is to check the supplementary material. So that's the place that people most often share these code sets. So if you find a paper that's working on a primary care database and they've found a condition that you're interested in, check the supplementary material, their code set might be there. But there are also repositories, and these three are all in the useful links at the end as well. There's one that the authors of the 2014 study created here in Manchester called Clinical Codes. And it's linked to study. So you publish a study and you upload your code sets there. There's open code lists. This is the one that's related to the Open Safely project that I talked about previously. And then there's the Value Set Authority Center in the US. It is a bit more US focused, but it does have some Snomed lists. So it might also be a useful starting point. So I would say that sharing and reusing is great, but there's a couple of caveats. What was the intent of the code set? So I talked about an example of two papers, same question, same data, they got different conclusions because of their code sets. It's also, or at least I think it's very hard to trust the code set without some sort of validation. And that's hard because if you want to validate a code set, so I say I give you 100 codes, you need to go through that list and check every single one to confirm that it should be included. But then the harder task is you've then got to search the rest of the dictionary in case I've missed anything. And then if I did miss anything, did I deliberately miss it? Maybe I thought it shouldn't be included, or maybe it was an accident. And I would argue that this validation is almost as much effort as just creating it from scratch. And so this is one of the reasons why people do create them from scratch. So a couple of years ago, I thought, well, there must be a better way of doing this. And so the final thing I'm going to do is introduce what I call term sets. So the term set, instead of a set of clinical codes, we have a term set. So we have got a set of inclusion terms. So these are things that I want to search for. And it's fairly simple, but we search the terminology for all those inclusion terms. So anywhere the term myocardial infarction or chest pain appears, and we get those codes. We then go through the ones we've returned and take out any that also then match the exclusion terms. So I'm getting rid of the family history of codes, the ruled out codes. And then at that point, I then iterate and I keep on adding inclusion and exclusion terms until there are no unmatched descendants. And I'll explain that graphically in a second. And so what we can do is we can always, from a term set, uniquely derive the code set for then use in our analysis. This is the hierarchy of a code set. So I search for the term myocardial infarction. And these green blobs represent any code whose definition contains myocardial infarction. I then apply the exclusion terms. So perhaps these red ones over here are family history of myocardial infarction, because they're codes I don't want. But now what you'll notice is there are some squares, these yellow ones, where these codes are descendants of codes we've matched, but we currently don't match them with either our inclusion or our exclusion terms. And this is the problem I was talking about before, where we don't know if someone gave us this code set with just the green blobs, we wouldn't know if those yellow ones had been deliberately excluded or accidentally missed out. And so with our methodology, we say, well, okay, what you need to do is you need to look at the descriptions of these unmatched descendants. Because in theory, if you're matching the parents, so over here, if you're matching this, the top green blob, then the children of that code are examples of that code. So you probably should be including them, unless the terminology is formulated wrong, in which case you might exclude them. So we say, well, okay, you look at those, you find the definitions, and then you add inclusion or exclusion terms until every descendant has either been included or excluded. And this also helps with the searching process, because if those codes should be included but weren't matching the phrase myocardial infarction, then that suggests there was a synonym that I'd missed out. And so by using this process, it actually helps us find synonymous terms for what we're searching for. And the reason why we think this is better is because previously, here is what I would share with you for a type 2 diabetes code set. So 100 codes, it's a lot to go through. Whereas now, it's this. I specify the terminology, read v2, and I specify the release. I'm including type 2 diabetes in Roman numerals, and non-insulin dependent diabetes. And then I'm excluding Reven syndrome, diabetes review, in remission, family history of, and in pregnancy. So now, if I share that with someone, my intent is now a lot clearer. And if they wanted to reuse this, they might say, well, yes, I will reuse this, but I want to include Reven syndrome. So all you need to do is you just take away that exclusion term and then derive the code set from it. Now, in order to do that, I've created an online tool which allows you to create term set code sets in this way. It's currently set up for Snomed, CTV 3, and Read version 2. And this is the link. I'm giving no guarantees. I am one person. I developed this as part of a project. I'm not. essentially, we did a paper and we showed that no matter what code set you could come up with, you could always represent it with a term set. So that shows that there is an equivalence there. And we then also showed that it was better on the metric that term sets are smaller. So we found a load of code sets in the literature, we represented them with a term set, and we showed that the number of inclusion/exclusion terms was always less than the number of codes in the code set. So on a metric of size, they were always smaller, which probably means that, or at least we propose that it's easier for people to review them than reviewing all the codes itself. So we've talked about clinical codes, we've talked about clinical code sets. I've described my version of code sets called term sets. We showed it's more as expressive but more efficient. We believe they're easier to share, inspect, and reuse, and the expectation is that this will benefit transparent and reproducible research if people adopt them. This is the page of useful links around the terminologies, the code set repositories, and I guess when these slides are shared, you'll have access to those. And so with that, I'll draw it to a close. And at this point, I'll take your questions, and we're happy to do more fairy tales if there's a wish for that.
Thanks so much, Richard. That was really informative and extremely useful. There are a couple of questions on the chat box already, so we'll have those first. And the first one was from earlier in your talk, and it was about whether any of the primary care data sets include Scotland and Northern Ireland.
I mean, I'm almost sure that there will be data sets that include Scotland and Northern Ireland. I know of studies that have used primary care data in Scotland. So
okay,
definitely for Scotland, it will exist. I don't think any of the ones I listed do, but there will be definitely something in Scotland. That's just I haven't come across it.
When working with different coding systems, could there be important exclusion terms that appear in one coding system but not another coding?
Yes. So I mean, the way I would come with exclusion terms is I'd start with the inclusion terms. I would search for codes, and then I would see what comes back. And obviously, if you search for the stroke and one of the codes is family history of stroke, then immediately I think, oh yes, I should be excluding family history of. And then I'd iterate at that point. In terms of the sort of the second point around different terminology, so yes, to some extent, when you create a term set or a code set against a single terminology, you will often find that because of idiosyncrasies in the way that terminology is the descriptions, you might end up with strange inclusion or exclusion terms. And so when you then change that to a different terminology, it can cause a bit of an issue. But actually, I would say that it's actually a positive thing because, well, particularly with the tool that I've developed, what you can do is you can create a term set against one terminology, and then you can just flip it to apply it to a different terminology and see what you get back. And I find that you can usually, well, actually, I've always found that you can come with a term set which is actually sort of agnostic to the terminology. And the benefit of using multiple ones means that you are more likely to find synonyms for things that you might have missed in one terminology, because you're using the power of the hierarchies across multiple terminologies and not just a single one.
Whether you're familiar with a site called portal.caliberresearch.org for finding clinical code sets, and if so, do you recommend it?
I'm aware of Caliber code sets. I haven't used it. I mean, in my paper, I wrote about it because they have a method for creating code sets as well, and so part of the term sets is based on the things that they have done. But I don't actually have an experience of their portal for code list itself.
So what happens to codes or systems that are no longer used? Do they stay archived? And do the companies own the rights to the code terminologies? I think that's an interesting question, because that whole looking back over time, at least in my experience, can make your life a lot more difficult when there's changes. So things like going from ICD-9 to ICD-10, or different HRG version. I'm only familiar with hospital data rather than primary care data. So.
Recode version 2, the dictionary is still available. It's getting harder and harder to find. One of the links I've got is to NHS Digital, and you can, in theory, download dictionaries from there. But it is getting harder to find the ReadCode dictionary, and I think you actually need to sort of just email them. It's no longer just available for a download. In terms of just, I guess, how things change over time, one of the issues is that you do get new codes appearing over time. So someone's code set from 5 years ago might not be valid anymore because a load of codes have been added. But that's another reason why term sets are quite powerful, because it can say, well, this code set was developed from this version, but now this version's available. Let's reapply it and see if any extra codes appear. Oh, yes, they do. And in terms of the proprietary side of things, and it's hard to get hold of those codes, which does make it a bit awkward. Though I would say that EMIS do try and map their codes to the real code when one appears. So most of the time it's a new drug, a code hasn't been introduced, so they add an EMIS code quickly, and then a few months later they map them all to whatever the code in the standard dictionary is.
There's a number of comments just about just how useful this talk has been, and I couldn't agree more. It's fantastically practical advice, which I think everyone's really appreciative of. Oh yeah, let's have one more fairy tale. Let's do that.
Newlywed, infertility problem, specific food craving, unborn child subject to child protection plan, female baby, imprisonment, abnormalities of the hair, fall from turret, accident caused by plant thorn, foreign body entering into eye, occurrence at other specified place, acquired blindness both eyes, length of time homeless, tearing eyes, patient cured. That is Rapunzel.
Brilliant. I can't believe there's a code for fall from turret. I love that.
Yeah, there are 1,000, well, there's hundreds of codes for falling, and there's just like, you've got things like fall from burning building, fall off burning boat. It's like
fantastic.
Someone was having a joke one day.
Oh, I love it. Well, I think you're just going to have to imagine the sort of, the waves of, rapturous applause that you'd be getting if you were actually in a room with us right now, Richard, because I think that was really excellent. We all loved it, and we all learned a lot. Thanks so much for your talk, and thanks everyone for joining us this morning, and for useful and interesting questions. And a huge round of applause to Richard.